Hi, I'm Mr. Rose. I'm from the CPU program, and I teach calculus and vectors and advanced functions. So, the app I'll go over today is Sketch Explorer. This is the iPad version of Geometry Sketchpad, which we use a lot in math courses in CPU. If you open up Sketch Explorer, basically what it is, you can open up GSP files. You cannot create them. So you'll have to, the ones that we use in class on a day-to-day that would just normally be on the projector, we can have you guys play around with them by yourselves in class as well, so you can make your own discoveries. It's almost like having a little computer lab in class. So what I'll be doing more for next semester is adapting a lot of the GSP files that I have for more iPad-friendly usage, because some of it is not, some of these files as they are not completely usable yet, because I need to show more buttons. So this, for example, is a 3D vector plotter. You can adjust the 3 different coordinates to show how something works in 3 space. And for calculus and vectors, we also show them how to plot vectors in 3 space. So it's nice to be able to show them a good representation of what a 3D vector looks like in calculus or in vector spaces. Some other ones, like the one I did today. Here what we're looking at is we have, we can show that the rate of change of an exponential is also another exponential graph. So there are a few proofs in the beginning of taking derivatives of exponentials that are a little bit difficult to do with equations, and even if you did do them, the students probably wouldn't get them that well. But what you can see here is that if you have the derivative here, you can actually match the derivative with another sort of adjustment to the equation. So by going with this sort of assumption, then when you go to plotting what that ratio is, because what we did here is we picked a value c, it ends up being a constant that you could multiply by. When you plot that sort of constant over as you change the base of the exponential, you can start to see what sort of function you get, and that's what we're tracing out here in green. So rather than students just see what I'm doing in class, they can all go through them themselves. And what you can see here, there's a little bit of humor here, just so they don't just skip to the conclusion. I made a few buttons for them. What this actually ends up being is that that constant that we multiplied before was the ln of the base. So this is a graphical proof of the rule that the derivative of an exponential is the exponential times ln of the base. And so anytime we have a GSP file like this, this is an example of one that I've made ready for iPad usage, because you can't edit everything as they are, but if you have buttons, then you can go through everything yourself on the iPad. One very nice free app on the iPad for math is this free GraphCalc. It's just a free graphing calculator on the iPad. One thing that shocked me was that how user-friendly this one is. With the usually every semester in advanced functions we have to get our students to buy 400 plus ringgit graphing calculator. That is honestly hard to use because there's a lot of learning curves to go with it, but within a couple of minutes with this one I was up and running, and I think for other students that can pick up technology quickly, this one is very easy to use. So there's room for 4 functions, and it's all in color, which color already puts an advantage over the TI-84 or TI-85 because they're still black and white screens. And there's a big keyboard that you can see to put things in. If you need your variable x, it's just right there. There's no alpha, x, like multiple buttons just to get a certain key, so I'll clear that. If you need a more complicated function, if you just hit the function button, you get a nice menu of different functions. So we can try, let's put in log of x, put that in, let's just add 6. So we can save that, they get saved there. We can put a second function in. We'll just put x squared, maybe, x squared. So now when we graph this, one of the annoying things about the TI-84 and TI-85 is if your window, like your X and Y windows, aren't perfectly set, then you have to go back and change that manually. But with that nice iPad functionality, you can actually just pinch and zoom however you'd like. So you can adjust the window on the fly, which is much, much, much nicer. And so if you're looking for an intersection point, the only direction you really need to tell people is to get the menu, just double tap the screen. So there's a few different things you can do here. If you just want to see what the values of the points are, you can just drag your finger along the graph, and there's a blue point that follows the blue graph, and there's a red point that follows the red one. So up in the corner here you have in black the x value, in red the y value for the red function, and in blue the y value for the blue function. And again, it makes finding things like intersections very easy. Normally we'd have to spend maybe half a class just showing how to use the intersection command on the TI-84. Here you just trace along, and then the program already kind of sticks to the intersection point. So you can see that it's at x is equal to 2.5-ish, and the y value is about 6.4. So in about, I think, a minute, students could catch on how to find an intersection, as long as you tell them to double tap for the menu. They can find the roots. Again, it's the same sort of idea. The function will, it's having a little bit trouble with this one. I don't know why, but normally it will stick to the intersection point as well. And you can do the same thing for finding max and mins. It's all with that same sticky sort of function. So you just need to know what you're looking for. One thing that's missing from this is making like a regression or anything like that. That's another useful feature of the graphing calculator. But in terms of graphing capability and just maybe computations, this is much easier to use than regular graphing calculator, and we'd like to try and find a way to replace, the 400 ringgit purchase of a graphing calculator with something free if you have an iPad.